Hello everyone. Now this section of paper 1 grade 12 maths is probability and counting principles. So we'll carry on those past papers and looking through the memorandums, and there are some questions we will spend more time on it. Now let's start as this 2014 EC trial question. This section is the last section of the paper. It's around 15 marks out of 150, so 10% of the paper is this probability and counting principles. Now, in Venn diagrams condition, most of the questions Venn diagram is given as the number of people or number of elements in that group inside R or inside C or inside G. So these letters represent different conditions, like R represents the people, it's the number of people who enjoy listening radio, and C is who enjoy gardening, G, and C are the people who enjoy cooking. So with the initials it is R, G, C, and altogether we have 115 people. Now all these people are inside this sample space. It's sample space is S, the rectangular shape. So those numbers inside sample space should be add up to 115. Now, how many sections we have when there is three sets? It's like only R. We can actually just name it quickly. So when we have two sets, for example, and inside the sample space, we will have 4 partitions. But when we have 3 sets, like in this condition, we have set 1, set 2, and set 3. Then all these are inside the sample space. So let's just count the partitions to remember. There is like only A, and then there is A and B, and there is only B, and there is the people outside. So it's 4 sections. But when there are 3 sets, let's say A, B, C, how many sections we have? There is 1, 2, 3, 4, 5, 6, 7, and the outside 8. See, it was only 4 partitions when there is 2 sets, but then when there are 3 sets, there are 8 partitions. As you see, there's those sections, the ones outside is Y. Okay, now actually the questions are just 1 marks. That shouldn't take that long anyway to answer. Let's see. If there are 28 people enjoy gardening, so those people inside G, that's add up to 28. So that information is given. So those numbers inside circle G, which has 4 parts, must add up to 28. So when you add them up, so it is x plus 7 plus 3 plus 10, so these numbers makes 20. So to be able to get 28, x is 8. You just say it, x is 8, okay. And what they refer, like 3 people just enjoy gardening, not radio, not cooking. 10 people enjoys cooking and cooking and gardening, but not radio. 7 people enjoys radio and gardening, but not cooking. And x is where they all 3, those x number of people, which we end up 8 as the answer. So those 8 guys, they like listening radio, cooking and gardening. They like all 3 events. Now determine the value of y. Now to get y, so we can substitute x as 8 into the values that we got. So since we got it is 8, so those people who enjoy cooking only is 20 minus 8, so it is 12, and radio only is 47 minus 8 is 39. So we will add all of them, and it's basically 115 minus all others. Okay, whatever the answer is will be the value for y. So we will add all other 8 values. So 39 plus 23 plus 12 plus 10 plus 8 plus 7. Okay, all these others we will subtract it from 115y, because there's 115 people. Okay, there are 5 loaves of bread B and 7 loaves of white bread on the shelf. It is okay. 2 clients, one followed by other, each randomly select a loaf of bread. Okay, determine the probability that the first client takes a loaf of white bread. So what's the chance if he randomly selects, if it's a blind person, so he just picks up a bread just like that. So it's what's the probability definition? It's the actually probability of picking up a white bread is number of white breads over divided by number of all possible breads that he can or she can pick up. So it's basically 5 brown and 7 white. That is 7 over 5 plus 7 over 12, that's it. You can just write the answer, full marks. Assume that the owner of the shop doesn't replace any loaves of bread on the shelf after a client has taken a loaf. Determine the probability that both clients take a loaf of brown bread. So we must have the first one taken brown, and then even the second one must be taken brown. So what's that chance? So it's basically probability of, we can say, B and B. So the first one to be brown is 5 over 12, okay? And then times the second one. Now how many brown bread left? It's 4. And how many breads altogether? It was 11. You see, it's not replacing. The shop owner doesn't replace anything. So it was 11 loaves left. And the second one to take brown as well has 4 out of 11 chance now. Because that says both clients take a loaf of brown. And that's the answer. You can just use calculator, or 3, it's 5 over 33 as the chance. And then the last question here, if the first client takes a loaf of white bread and the owner shop places a brown bread, the owner loads on the shelf. If the first client takes a brown, the owner of the shop. Okay, like the owner of the shop, this is like playing games, huh? Determine the probability of that a loaf of white bread and a loaf of brown bread is sold to the two clients. So to be able to see it better, we draw a tree diagram. So the first one can pick up a brown or a white, and after that the second one can pick up a brown and a white as well. So our tree diagram will be just like that: BW, BW, and BW, and BW. And obviously we have outcomes. And what are the outcomes in this case? They can be both BB, first brown then white, white and brown, and both white. So those are the outcomes. Alright. Now what's the probabilities? Let's just focus on there. So we had the 7 white and 5 brown, isn't it? So it was 5 over 12 for the brown, and 7 is white is 7 over 12. But now when a loaf is taken, there is a 1 which is replaced. So but what is replacing? It's the other way around. If brown is taken, then the owner puts another white now. So at that time brown decreases 4 and white decreases to 8. So it's divided by 12, both divided by 12. Okay. And now if white is taken, the number of white decreases to 6. So it will be 6 over 12. It was 5 brown, but the owner add another brown since white is taken. So he plays the game. Remember, he puts the other way around. So number of brown breads becomes 6 as well. So it's now they are equal, 6 and 6. So each one is 6 over 12. Now, what does the question ask? The probability of a brown bread and a loaf bread in sold to client. It doesn't ask in any order required. So we just need to find BW and WB conditions. So we will add them up. Then we can write the answer down here. Probability of BW or WB, probability BW plus probability of WB. Let's find it. So for the first one, it is 5 over 12 times 8 over 12, and then plus the second one, 7 over 12 times 6 over 12. Okay, so once you get the answer, you can basically just smile over there. So that's BW and that's WB. Add them, divide by 2, so it divide by 1, 4, 4, it's 40, 42, 82 over 144. So it's 82. Basically, you can divide by 2, 41 over 1 over 72 maybe. Okay, so something like that. Alright, that was the question of how many marks. It wasn't the only question, I think. We don't see the marks. Now, the memorandum is here. Good. As you see that the last question, we must have written those options with the tree diagram, which helps us to see what's happening. Alright. Okay. Was there any other question? There is something in the memorandum, but there is no question here. Anyway, we'll carry on. Now the Hauteng paper. We have Tebo writes an art and music examination. So he has 40% chance of passing music and 60% chance of passing art. And then 30% of passing both. Okay. Now it's basically, we will just apply that formula because we are given PM, it is 0.4, 40% chance, and art is PA, that's 60% chance, it is PA I mean, and art and music passing art examination both is what? PM and A, so that's 0.3. So what's the question? It's P, M or A is the question. So just apply the general formula given in the formula sheet, so that wouldn't be problem. Just add them, divide by 2. What is the formula sheet? It's PA or B is PA. This is given as a general formula which can be always applied. It's PB minus PA and B, you know this general formula which always work. There are special conditions for mutually exclusive and independent events, but this formula always work. Okay. So 13.2, now this contingency table given, it is difficult to figure out what is ABC without knowing one of them. But we have given an extra information. It is given here, independent events. So if this independent events, there is no relation, there is no dependence between higher color or a hand used left or right. If there is no dependence, if they are independent, we can just use the idea of independent events condition. And what it should remind us, independent events happens to be, it's a relation between PA and B between two sets. It is always the product of PA and PB. Now, you can just decide which one to be your set A or which one is your set B. So maybe I can just focus finding A. So I can say right hand is my one set, and the light-handed L is the other set. So I can focus to find A. Okay. So what is my A? The people who has number of people who has right-handed and light hair. And what's the chance of getting such people? It is A over 60. We don't know A, it's A over 60. So I will do that. Probability of getting right-handed people is basically how many right-handed people are there? 48 over 60. And probability of having a light hair, so it is how many light hair guys there? 20 over 60. And what is probability of right-handed and light hair, R and L? That's A. A people are there, but we don't know A. It's A over 60. Now, according to this information given, what I can say, A over 60 must be equal to, because I am using the idea of independent events condition, it is equal to the product of the other two, 48 over 60 times 20 over 60. So from here, I can get A, and then after A, I can get anything I want, okay? That wouldn't be a problem. Now, the digits from 1 to 9 used to make 5-digit codes. Good. So, the important thing, it's code, okay? It's not an integer. So, the first digit can be 0, but anyway, okay, we don't have any 0 anyway. It's 1 to 9. Determine the numbers of 5-digit codes possible if the digits without repetition. So, we can have 1, 2, 3, 4, 5, 5 chairs. You can use the chair method. So, the first one can be placed with any 9. So, because without repetition, I have to decrease by one in each time, because then the ones used cannot be used again. So, this is the answer. Now, determine 5-digit code possible if the code formed to be an even number and the digits may not be repeated. So, now when it is even number condition, it depends. We need to focus on the 1, 2, 3, 4, 5 chair method again, but this time we must focus on the last digit first. The last digit should be, okay, to be even number, we must focus on the last digit, and last digit must be what? It should be 2, it can be 0, there is no 0, we have to choose it from 2, 4, 6 or 8. So how many options we have for the last digit? 4 options. So that's where we start. Now we will multiply by what? So we still have 8 other numbers. So one of the even numbers written in the last place, but any other 8 can be written in any other positions in any way. So that's why The others I can just write 8 times 7 times 5 in any order, okay. I can say 5 times 6 times 7 times 8, but times 4. So here what important is we write 4 first, and then the others same as other decreasing options that comes there. And then the last question, determine the 5-digit codes possible from even digits, repetition of digits allowed. So important, only even digits. Alright, now what are my even digits again? 2, 4, 6, 8. And then one more thing, we have 2, 4, 6, 8. Now we have 5-digit code, but what is important, something is allowed. It has to be allowed. Why? Because we don't even have 5 different even numbers, so we have only 4 possible even numbers. That's why when we are having like our chair method again, for the first position it can be any 4, and then the next one can be any 4. So we can actually write 2 2 2 2 4 4, or 2 2 2 2 8 8, or 8 8 8 8 6, whatever. So the answer will be 4 to the power of 5, because of what? Repetition allowed condition. So we don't have any problem over there. Okay, this solution is here. Another question, we are given A, not A, and B. So if it is not A given, what is PA? It is 0.55. Oh, that's the first question anyway. So that formula is not given, that relation. What relation is that? PA and not A, P prime is always 1. Okay, it's like to be or not to be. Shakespeare says it's 100%. Determine PA or B, mutually exclusive events. So here we will be just using the formula. Now that general formula, let me write on the top again. What is PA or B which always work? It is again PA plus PB. You can write and then minus PA and B. And what we said, if you remember, that last part can have 3 options. So it can be anything, it can literally be anything, or it can be PA times PB, that makes it a special condition, independent event, or it can be 0, that makes that special condition as well. So so that can be anything. I don't have any problem with anything. But then if it is independent events, it's the product, and if it is mutually exclusive event, that's 0. So the condition may not be mutually exclusive or may not be independent. It can literally be anything. But if it is mutually exclusive, like this question says, or the second one says, if it is independent, then it has to satisfy the condition of the multiplication of, or it has to satisfy mutually exclusive event. It's the 0. So we can just write the answer. Actually, we know what is that first answer: 0.55 PA plus PB 0.35 and minus 0. That's the answer. And the second one, 0.55 plus 0.35 minus the product, 0.55 times 0.35. So whatever the calculator gives, those are the answers. You can just smile and smile. Okay. All right. Blue, green bucket of wealth with balls, 5 red, 3 red, 2 right, the bucket random select, 1 after random drawn from. Okay, so we have blue and green buckets are full with balls. Okay, and then draw a tree diagram to represent above information, clearly indicate the probability, all the outcomes and everything. Okay, so what we need to write, it is first we will choose the bucket, which is B or G, and then each one you will choose one of the marbles, and probability of choosing the red ball. So I'll just go through with the memorandum because it's already drawn. So what you need to draw, as you see, first step of our selection is basically selecting the bucket. It is either bucket B or G, but from B we can end up getting white or red marbles. Actually, even from G we can end up having white or red marbles. Obviously, the probabilities are different. Now, there is no way of, like, there is one blue bucket, one green bucket, so the chance is 1/2. Okay, it's not like you more likely choose the blue one or the green one. They are equally possible to choose one of them. But now, once we have B or once we have G, inside B, depending on the number of marbles, the probability of selecting white or selecting red changes. You see the probabilities are now different. What are they? 5 over 8 because, and then 3 over 8. But in the second one there is less white, so it is 2 over 9, and there is more red, 7 over 9. So when you are writing a tree diagram, you must write all these options with the probabilities and the outcomes. Okay, just observe the memorandum how you get part marks. And then if they ask us, you know, to what's the probability of selecting red? So red is BR, choosing, you can select red from the first bucket, or you can select from the second one. From the blue bucket you can select red marble, or from the green bucket you can select red marble. So that's why it is the sum of these two. Okay, so you just add them up and multiply, okay, those roots and add them up, as you see. Alright, then question 11. There's a number plate question. It's kind of accounting principles. Yes, we have what? 4 number plates. The new code consists of 4 letters like this one, and then 4 digits and another EC. So EC is fixed, but those B, C, D, E, F can be changed and the numbers can be changed. But is there a condition? Yes. What is that requirement? The vowels and Q may not be used. Okay, how many letters are there? 26. So those 5 will be missing. And then letters 1 to 9 except 0, all the letters can be used. And it can repeat. So it can repeat means if we have 21 options to write a letter, so it will be 21, 21, 21. It doesn't decrease because it can repeat. Or even the digits. We have 9 options except 0. It can be any 9, 1 to 9. So it is 9 times 9 times 9 times 9. Okay. So that will give us 11.1 number of possible codes. Now 11.2, provide that code randomly selected will consist of even digits which are not the same. Okay, so first it is asked the probability, so we must divide that answer with our previous value. So we must find number of ways that can happen. So even digits, which will consist of even digits which are not the same. So what are the possible even digits, by the way? So we must use 2, 4, 6, 8. Okay. Now how many spaces we have? We have only 3 spaces for the digits. See, for the numbers it doesn't really change. I mean, for the letters it doesn't really change. What is that? If it is 21 times 21 times 21 times 21. But now for the digits it can be any 4 first, and then because not same it will decrease. I will decrease it to 3, 2 and 1. So that's the possible ways of writing even using only even digits. And this will be divided by our previous answer. Alright. So let's just check if that's in the memorandum. As you see, yes. They actually say that 4 factorial, as you can see, 4 times 3 times 2 times 1 is 4 factorial. And yeah, that's 4 factorial. And that's 20. Oh, it's not 21 because from 26 now how many numbers we have left? 1, 2, 3, 4, 5, and Q may not be used. Oh yeah, 6 numbers already gone, so that's 20. So out of 26 we got 6 numbers already gone. That's why those chances are 20 and 20 and 20 and 20. And in the first one, what was it? We said because it can repeat 20, 20, 20 and times 9 times 9 times 9 times 9. Okay, so that's all fine over there. As you see, that's the first one. And then the answer must be divided with our previous condition, and that's our second probability. Remember, probability must be always between between 0 and 1. So we must have a decimal or a fraction. Alright, there's another bag question. A ball is taken randomly from one of the bags. So what we will do, we will select a bag which is 50% chance, and from then we will select a marble. So then you will decide according to that. This is just like the previous solution, so we can even check the memorandum. The next one represents this information in Venn diagrams. Okay, Venn diagrams may have like number of elements written one by one, or usually we are given with the individual terms. Okay, but sometimes like this question you can even write the probabilities. All right, So like we can have all individual elements, like in a Venn diagram, for example. You can have, let's say we have the numbers less than 10, the prime numbers, odd numbers, whatever the set. So those numbers can be all written. You see, set A, let's say I'll write prime numbers. So 2 is the even one, then it is 3, 5, 7, and then the 2, 3, 5, 7, and the even numbers. So 2, 4, 6, 8, and the ones outside, 1 is not there, 9 is not there, and then 10 maybe. Yeah, you can write 10. So I wrote numbers 1 to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all are written. So that is one way of filling in a Venn diagram. But usually what we do, we usually write the number of elements inside in each section, in each partition. And this is the third option, as in this question. We can even write the probabilities. Now, in this case, we have the set. So the intersection will be written as 1 over 6 P, A, and B. Okay, so that's our A, that's our B. So inside P, A, and B, that's 1 over 6. So that's, I fill that information. And not A and B. So not A is outside A. So you can say not A is outside circle A. But then inside B. So that is here, 5 over 12. Okay. It's outside circle A, but inside B. Because it says and B. So it will be outside A, but inside B. That's why I fill in 5 over 12 there. And then the last one, 1 minus A or B. So A or B is, what is A or B? It's actually when you have the sets, it's this whole thing. Remember, A and B is the intersection point, A or B is this. So 1 minus that means the outside. So outside is 1 over 3. And finally, that part is missing. I can say X. And how do you find X? This time the number of all these probabilities has add up to 1. That's how you get X, for example. Okay, so you can get X, and let's find it. You can say X plus 1 over 6 plus 5 over 12 plus 1 over 3, that's equal to 1. So from here we can get X. And then, yeah, PA is easy then, X plus 1 over 6. That's the answer for PA. Now, that's just a 1 mark question, but let's see. A team of consist of 4 learners needs to be selected from beginning of the year. The learners chosen 11 A, B, C, D, and randomly to be selected. So we are going to select 4 learners. Good. Calculate how many different ways this team of representatives can be selected. Okay, I think it's just like their product, because it's like 4 chairs. The order doesn't really matter. You can just select someone from class A. So is there any restriction? No, not really. So you can choose from any 20, then from class 11B any 15. So it's any 12 and any 10. So that should be the answer then. That's number of ways. Okay, so you see the solution here. Good. Mutually exclusive events determine. You see, since you read that information mutually exclusive, you know what? I can just write that answer is 0 straight. You don't need any calculation. That's 0. And the first one was 1 over 0.35. You know that. So the questions become easier now, as you see. So you got 2 marks, you got 1 mark. And PA or B, you just use that formula, which is what? PA plus PB minus PA and B. But you know you are going to subtract 0. So that's an easy condition as well. And then the next one, married couples to be seated on a bench. How many different arrangements are possible? Okay, now how many people are there? So there are 6 people. Without any restriction, 6 people has 6 factorial arrangements. Okay, so that's why that first answer is 720. There's no any restriction. We don't want the couples next to each other, whatever condition, nothing. So if Mr. and Mrs. Green must be seated in the middle, how many different arrangements are possible for the remaining persons? So now we better use that seating idea, the chairs. So we have 1, 2, 3, 4, 5, 6 chairs. In the middle, it is either Mr. Green or Mrs. Green. So it is 2 times 1. First one can be Mr. Green, the other one can be Mrs. Green. Now, the other 4 seats, it can be randomly chosen by the remaining 4. You see, it doesn't need to be like in the right side can be both males or a couple or any order. That's why I will write the others 4 times, 3 times, 2 times 1. So I put them in different colors because that's like different arrangements. So the answer is basically 2 times 4 factorial, maybe you can say that, or 4 times 3 times 2 times 2. So whatever you say. Okay, that will be the answer. And now the probability, that's the keyword here, we must divide this condition, that Mr. and Mrs. Green will sit next to each other. Okay, next to each other question, we use stick method. So like we have those two and the others. So what's the stick method? How do we solve it? They become next to each other like a fat person. So remaining other 4, that makes 5 people. So it's like 5 factorial now. And then obviously they can swap in between. So it's 2 factorial. So that's the number of ways that two particular person, in this case Mr. and Mrs. Green, sit next to each other. But then we will divide that answer by 6 factorial because the question asks probability. So basically the answer is 5 1 over 3. That's the chance. Okay. So the solutions should be down there as well. Okay. Then we have this Venn diagram question. I will leave this to you, but just I want to have this idea. Start filling in from the most inner part. That's the most important thing now in such questions. Start filling in from the most inner part. Let's say that way. Most inner part with the intersection and everything. So that helps to have these idea run, because let the number of parts both swimming and gymnastics but not athletic be x. So they tell you one of the sections will be x. So draw a Venn diagram. So we have swimming, gymnastics and A. So you can say there is S, there is G and there is A. So we have 3 sets. So okay, let's just we will draw 3 sets always in this way. Remember, don't forget drawing what? Drawing the sample space. All is fine. But what we use first is, okay, let's write the letters. So there is that's my S for swimming, that's why G, and that's why A. So sample space, okay, let's just write sample. Now where can we start in filling in? Those who participate all 3 events. So that's number 1 I can write. Okay, let me write 1 so that I write 9 first. And then 99 participated at least 1 event. So I can use that information separate because I know there are 80 participants. So then 80 minus 69 will be 11. So that's my second thing to use. Okay, so let me write them in front of the information. So the first information I use is that 9 people. Second information I use is this. So how? Because 80 minus 69 gives me 11, the people who are outside, who doesn't do nothing. And 11 participants remained as real for the 11th, didn't participate. Oh, that one given. So that's like unnecessary information because I already know they add up to 80. So as long as they add up to 80, nothing is tricky. That second last information doesn't really need to be given. Now, 23 participated swimming and athletics. So 23 is swimming and athletics. 23 minus 9, I'll write here 14. So that's number 3 I can fill in. 19 GA, so 19 minus 9 is 10. So that's number 4. And one more thing we can say. What is that? They actually tell us where to write X. So swimming and gymnastics, but not. So that's X is given already in that question. That's X. And the other parts I will use those numbers in writing in terms of X, and some of them will be like the sum minus X or something. But let's find A, because A is how many? 39. So I can write that as the last one, because 39 from 31 I subtract the others. So 14 plus 9 plus 10. So that gives me what? 20. That gives me 6. So that's when I write 6 athletics only. So I'll find S, G, so then it's filled in. So the sum will be 80, and that's how you're gonna end up X is 5 for the next question. Alright. And probability of that participant chosen at random will participate in at least 2 of the 3 events. So at least 2 means, what is at least 2? Which sections I will take? It is 2 or 3. So I will basically take those exactly 2 and 3 as well. So this part is at least 2. So I'll add all these numbers including x. So basically it is 5 plus 9 in the middle. Okay, let's write at the 2 ones first. So 5 plus 10 plus 14 and plus 3, which is 9. All 3 is in the middle. This divided by 80. Okay, because it's probability, don't forget. So we are adding all these numbers. There is like 5 for x, then there is 10, then there is 14, then there is 9. We are adding them and divided by 80. Okay, education, how many unique ways letters above be arranged? So in such questions, we will just check, is there any repeated letter? There is no E, D, U, U, E or whatever. No, there's nothing repeated. So it's 1, 2, 3, 6, 7, 8, 9. So because they all different letters, it's like 2, 4, 6, 8, 9. It's like 9 people, 9 chairs. Okay, it's like 9 people, 9 chair question. So basically, you'll just say 9 factorial. And now, randomly chosen, 5 letters are randomly chosen from this. Determine how many unique 5-letter arrangements can be formulated. So, unique 5-letter arrangements. So, 5 letters will be chosen. That means it is different letters. You can just have, the first one can be any 9. But then it can be any 8, then it can be any 7, then it can be any 6, then it can be any 5. So this question becomes like 9 people, 5 chairs. So we are taking pictures because we are arranging them, okay? It's not like you're choosing 5 people out of 9. It's you are making them sit to take we are arranging them, you see? So that's number of arrangement. That's why it's number of arrangements we put in this order. Okay, all right, so you'll see the solutions here anyway. And then this question, it's almost solved, but I'll go through. We are given PA, PB. PB is K actually, and PA or B is given. So PA or B not, okay, that not is like, it's just 1 minus 0.7, okay. So because it is the opposite of complement of PA or B is 1 minus 0.7, you get the answer. Now, depending on mutually exclusive or independent event conditions, so we can have different values for K. So that's what they ask. You see, for the first one, PA and B must be 0. So we can always use that formula. So we know PA or B, 0.7 given. We know PA, 0.4 given. So we know PB, that's K. We will find it. And then minus PA and B. So that is in the first step, in the first condition, 10.1.2, it's 0 because mutually exclusive. So from here, I can just get the answer is what? K is equal to 0.3. That's it. But in the second one, now this time I won't put 0 there. It is the product of PA and PB. So it's 0.4K. So that will give me an equation. Like I can take 0.4 to the other side. It is 0.3. 0.3 and K minus 0.4K, so 0.3 is equal to 0.6K. So when you divide, so K is equal to 1 over 2. So basically in that case, you get K is equal to 0.5. So you get two answers. For the mutually exclusive condition, it is 0.3. For the independent condition, it must be 0.5. It's solving that two possible cases. Alright, now there's 10.2. It says we have 24 bags. They even draw the tree diagram, but some parts are missing. 10 bags has 7 green marbles and 3 yellow. So that's 10 bags, bag 1, type 1, let's say. And the other type, the other bags, which is 14. See, that's actually, you have 10 bags and 14 bags. So 10 of them has 7 green, 3 yellow. The remaining 14 of them has X green and 9 yellow. Okay, they all has greens and yellows, but different numbers. So it is 10 and 14. So since we just summarized that information over there, we can say what is M? It's probability of selecting that type of bag. So it's 10 out of 24. That's M. And then what is N? Is choosing yellow from bag 1. Let's say that way. It's the product of 10 over 24 and 3 over 10. You multiply it. That is N. Now, how do you find x, that number of green marbles in the second type of bags? That's the remaining 14 bags. So, because this x green, 9 yellow, how many marbles altogether? X plus 9. So choosing green is x over x plus 9. Choosing yellow is 9 over x plus 9. So now, and we know the final probabilities. I will select to choose those yellow root. Why? Because that's kind of easier. There's only one x in the denominator. So I will select that, and my equation is going to be 14 over 24 times 9 over x over 9 is equal to 7 over 20. So that's my equation. 14 over 24 times 9 over x plus 9 is equal to 7 over 20. You solve this equation, it is solved here, and you get x. And then finally, the question asks, what's the probability that a marble chosen is green? Oh, actually, we could answer that question without finding x. You see, green is this part and that part. You just add them up. That's it. You don't really need to find n or x or anything. You can solve that last question at the beginning of this, when you start solving this question. We don't really need to find what is m, what is n, what is x. We can just find the last one. Just add these two. They already were given there. Alright, now I have just a few slides left. One is the last question of 2020 paper 1, because that includes a little bit different idea. It was like Harry has a chance of hitting the bullseye 50%, then Glenda comes, she has the same chance of hitting the bullseye is 50%. Now, they take turns, they are having a challenge. Whoever hits first wins the game. Okay, that's their game. So the question asks, find the probability that the person who shoots first will be the winner of this challenge. So it doesn't matter who shot first. No, that's why I put yellows and a blue one. So yellow person, whether it is Henry or Glenda, will be shooting the first one, and actually he can win in the first shot. Then the other guy shoots. We don't want that other guy to win. And the yellow, it's the yellow's turn again. So this time, to be able to make him or her win, he must hit. So then he wins. So then if he can't hit, then the next guy comes. So that's how the game carries on. Whoever hits, see, we don't have any branches of tree diagram after H. When it is H, you stop. The game is over, that guy wins. But when it is N, when they couldn't hit, the game carries on. That's why the game can carry on forever. Like, couldn't hit, Harry couldn't hit, Glenda didn't hit, Dan didn't. You see, they can keep not hitting. I mean, it is possible. Like, they may not be hitting 100 times. It's a small chance, almost impossible, but it is possible in that regards. So, the first guy to winning of who shoots first is what? It must be PH, probability of hitting in the first place, or hitting in the third shoot. So it must be first one, not, second one, not, third one must be H. Or it must be the fifth shoot, which is not, and then hit. So then it carries on like that. So I think it gives the idea, it is the odd number of shoots must be the one who wins. Like, it must be first one, or the third shoot, or the fifth, or the seventh, or the ninth. And it goes in this order. It is either H, or NNH, or NNNNH, or NNNNH, it goes like that. Now, the good thing is what? Probability of H or N is same. Whether it is Glenda or Harry, doesn't matter. It is 0.5, 50% chance. So all these branches are 50% chance. 0.5, 0.5, 0.5. So that makes the question easy. Actually, it's just first one to win is 0.5 chance in his first try. Now, then the other two shoots must be N, the last one must be H, but still 0.5 times 0.5 times 0. So it's 0.5 cube. And to win in the third shoot, fifth shoot is 0.5 to the power of 5. So that goes infinity. So that makes a infinity geometric series. So I can just tell you what is A, the first term, what is R, T2 over T1. So as long as I know A and the ratio, common ratio, I can just apply the formula and get the probability of whoever starts the game wins. His chances or her chances 2 over 3. The other guy has chance to win 1 over 3. Okay. And this one, there's like number of 4-digit codes or 4-digit numbers. If using 0, 1, 2, 3, 4, 5, 6, 7, 8, okay, we have only 9 digits. Except 9, there are 9 digits, including 0. If digits can repeat, so it can be any 9 in any position, 9 times 9 times 9 times 9. But if it is a 4-digit number, it's a 4-digit integer, I cannot start with 0. That's why it is 8 times 9 times 9 times 9, okay. And then, if the digits cannot repeat, in that case, whenever it is code, I can put any 9 as the first place, including 0, nothing is wrong. But then, whatever is placed, I can put it again, I can write it again, so it becomes 9 times 8 times 7 times 6. Okay, what's the difference when it is 4-digit number? See, I can't put 0 again at the beginning, so I have the choice of any other 8. But then when it is the second one comes, so whatever written in the first place, I know it is not 0, but whatever it is cannot be written again. If it were 3, I cannot write 3 again, but I can write 0 now. That's why it's again another 8. So that's why it is 8, 8, 7, 6. Okay, I just want you to see the difference. Now, if you are looking for an odd number and the digits can repeat, so we don't have any problem with the first 3 positions. It can be any 9, any 9, any 9, except the last. The last should be one of the odd numbers. And what are the options for the odd numbers? So you can say it can be 1, then 3, then 5, then 7. So those 3 makes the possible 4 options for the odd number. Okay, and then when it is a number, a 4-digit integer, the only difference is the starting one. See, it cannot be 0, it cannot be 0, it cannot be 0. But then last digit must be 1, 2, 1, 3, 5, 7. So the last digit is still same. There's nothing wrong with the last digit. Alright, so it's 8 times 9 times 9 times 4. The middle digits, whatever written again, we can write it again, not a problem at all. But the next question, now that restriction comes. It's like the first one, but the digits cannot repeat. You see the difference? Cannot repeat. So because we cannot repeat anymore, we can say what can be in the last digit, any 4. Yes, whatever written in the last digit cannot be written in the first place. Okay, it can be 0, yes, all is fine except the ones written here. So you start filling in the last one, and then after 4 you write 8. Because whatever written as an odd number in the last place cannot be written in the first place now. And then it will keep decreasing. 7, 6. What's the difference when the digits can, when it's an integer? See, the last one is still same, it is 4. But now the first one is 7, still 1 less. Why? Because we cannot write the one which was written in the last digit, which is 1, 3, 5 or 7. And we cannot write 0. So 0 and that number, except the 2 numbers, one of them is 0, one of them is that number, we have 7 numbers left. And now there's another 7, and this 7 not decreased to 6 because we can write 0 anymore. That's why. So this time it is 7 times 7 times 6 times 4. Alright. Now, if we have a question, we're looking for a number less than 4,000. So less than 4,000 is just all about the first digit. So the first digit can be what? It can be 0, yes, because it's a code. It can be 1, it can be 2, yes, it can be 3, yes. So it can be 0, 1, 2, 3. So it must be 4 then. That was a mistake here. So it must be 4. Okay, so it's 4 times, because it can be 0, 1, 2, 3, 4. But when it is in the second option, in that case, we cannot have 0, but we can have 1, 2, and 3. So that's why we can choose one of those 3 options except 0. This time it is 3 times 9 times 9 times 9. Okay, so the answers are not correct and we can just fix it later on. So I hope you got the difference. Now, to be able to have a number less than 4,000, first digit can be any 0 or 1 or 2 or 3. So one of the 4 of them, one of these 4. And then the others we are fine. You see, we can have 0, 0, 0, 0. But here in the integer case, the first one cannot be 0. It must be 1, 2, or 3. So we have 3 options. The others still fine. All 9. All other 9. Okay, now we have less than 4000, but that cannot repeat. You see, cannot repeat makes that condition as we keep decreasing. So first digit, again, it can be any 4, just like the previous question. So then I should just erase those answers. And then it is 876, and here it is 3876. So what's that small difference? Same thing as above. You see, just like the one above, first digit can be 0, 1, 2, 3, 4, or in the second one, only 1, 2, 3, 4. Then the next digit is whatever not written first place, we cannot write it again. Everything else can be written. So it is 8 others, 6, 7 others, 6 others. So it is 3, then 8 others, 7 others, 6 others, then it is decreasing. Alright, now if we have a question asked more than 4000 and even, and it can repeat. So more than 4000, what are the options? You can have, let's write here, we can have 4, it can start with 4, you can have 5, 6, 7, 8. So how many numbers we have? 4, 5, 6, 7, 8. We have 5 options. As you see, as an integer, it is same, 4, 5, 6, 7, 8. So we don't have any difference having a code or an integer, because the first digit can be 4, 5, 6, 7, 8, 4, 5, 6, 7, 8. Nothing is wrong. It's 5 options. And then even number. Oh, okay, that's about the last digit. Last digit can be 0 or 2 or 4 or 6 or 8. So since it can be written, you say I shouldn't worry about like if I wrote 8 in the beginning or 4 or 6, can I write it again? Yes, I can write it again. It can repeat now. So I don't worry about that if 6 is written, I should be consider about it. No, nothing. Just say that 6 can be written again. So that 4, if it is written, it can be written again. It can be actually all 4, 4, 4, 4. That's why the middle numbers can be any number at all, 9 and 9. So it's 5 times 9 times 9 times 5. So even that one, as you see, it's code or an integer. It doesn't differ in this option. We don't have any difference between whether it's a code or, because we don't worry about 0 at the first place. That was the case making difference. Okay, and the last one. Last one is cannot repeat. It's an odd number, but now it is more than 4000. You know, it's an odd number, so we must consider about the last digit. So that's a clash here, because of an odd number, last digits can be, normally we can have 1, 3, 5, 7, and the first digits to be more than 4000 is, you can say it can be 4, 5, 6, 7, 4, 5, 6, 7, 8. See, there's a problem. What's that problem? The 5 and 7 here and the 5 and 7 there. So that's a clash. And because it cannot repeat, that's why I have to split the condition and I must add up. Okay, that's why we are splitting this and adding up in that way. So let's see. How do we split? We say starting 5 or 7. So if we start 5 or 7, we have two options. Only 5. So it's 5 or 7 basically. Those are the two options. We are choosing from 5 or 7. Two options, okay? So since 5 or 7 is chosen, whatever left, like 1, 3, and the other. Like if you wrote 5, I cannot write 5 again. I can write 7 maybe. If I wrote 7, I can write 5 maybe. Okay, one or the others, 5 or 7. So whichever not written. So I have 3 options there. From then I am free. I can just write any number which is not written before. So any other 7, any other 6. The middle ones in both cases are same. Here, if we start 4 or 6 or 8, that makes 3 options. And in the last case, you see, this time I don't have any problem with writing 1, 3, 5, 7. I don't have any problem. I have 4 possible cases. So then I have to split in this way, and I have to add the products. That was a bit different question. As the hardest question, I left here as a last option. Okay. Now my last page is coming. It is those 3 questions, and quick. Actually, we mentioned some of them. What is that? Next to each other questions. Arrangements of 4 girls and 7 boys. If there is no restriction, it's just 11 people, 11 factorial. And what we said, if the following questions asked us to find the probability, we will divide all these answers one by one with 11 factorial. See, if the question asks what's the probability of girls next to each other, then we find that answer, divide by 11 factorial. Boys next to each other, find that answer, divide by 11 factorial. But if it's just number of arrangements, then we just find number of arrangements like this. Alright, now, girls next to each other, remember the stick method, we draw the sticks, so we end up 4 girls and the other 7. So 4 girls make like a fat girl and we have other 7 guys. So 4 and 7, so that's 4 fat girl, 1 girl, 1 fat girl plus 7 people. So it's 8 factorial times the girls can be arranged in between. And when they are boys next to each other, so we stick them together. So it's 4 girls and the fat boy, so it's 5 factorial. This 7 comes because boys can be arranged in between. And if the boys and girls next to each other always, so it's like a fat girl and a fat boy. So it's 4 factorial, 7 factorial, and BGGB, so it's times 2 factorial. If there's a couple, will be next to each other, you just make them next to each other. The other 9 plus that couple, so it makes 10, and then 2 factorial. In case we have 4 couples, like a couple and couple and couple and so we have 4 couples. It's like 4 CCC and 3 people. So that makes like 7 factorial. But each couple can be swapped, you see. That's why it is 2 factorial, 2 factorial, 2 factorial, 2 factorial. And if the question asks not next to each other, such questions can be solved subtracting from all arrangements next to each other condition. Like if there's a specific couple, shouldn't be next to each other. So what was the answer for a couple next to each other is 10 factorial times 2 factorial. So you subtract this from 11 factorial when it is not condition. And a similar question can be asked like 5 maths books, 6 science books, 3 history books and 11 art books. So we have 25 books. So probability, okay, that's the keyword now. Probability of all the same kind books next to each other. So then you have SSS, so again stick method, you see we stick them. So we have 5 maths books can be arranged in between 5 factorial, 6 science books is 6 factorial in between, 3 history is 3 factorial and 11 others are 11, art is 11 factorial. And all these MSHA can be arranged as 4 factorial and this must be divided by 25 factorial. Alright, and the last question, we are finishing with this. Whenever we have, let's say, 3 red marbles and 2 yellow marbles, we have done such questions, but I just want to make you focus in this, like with replacement, without replacement condition, the probabilities change. You still can choose like red and y and red y, ry, so you can say r, y, y, whatever, and you can write the probabilities. With replacement, we don't have any problem at all, but without replacement, when we are choosing 3 marbles, we cannot have, imagine, 3 yellow marbles. Why? Because there's only 2. So if we have yellow one in the first place, possible yes. If we have yellow one in the second place, possible yes. But the third one is 0 over 3. It's 0 chance, you can't. So there is no y option. Okay. So just be careful to make sure that you are writing correct possibilities in the roots when there is no replacement. Because if you are chosen red, now the red marbles decrease, the probability changes. Or yellow, the yellow decrease, the probability changes. So each time it happens, so you'll get different probabilities. Just be careful finding that. Otherwise, with replacement, all is fine. See, probability of choosing red is 3 over 5. It's always 3 over 5, 3 over 5 whenever you are choosing a red. Yellow is 2 over 5. It's always 2 over 5. It doesn't change. Okay. And like in this first one, if it says at least 1 red, it's easy to find as 1 minus all red. You see, at least 1 red means 1 or 2. Let's just make it yellow. At least 1 red means it is all yellow. I was just written wrong. So at least 1 red means what? It can be 1 red, okay, or 2 red, or 3 red. So that's at least 1 red. And what is the option of opposite of at least 1 red? It's all yellow, no red. So 1 red, 2 red, 3 red is basically at least 1 red. So it's basically we subtract in the case of having all yellow from 1. And what is having all yellow is probability of 1 minus, it's 2 over 5 cubed. Okay. So that's at least 1 red. at least one yellow will be 1 minus probability of all red, just other way around. Okay. And if we have exactly 2 reds, so just be careful, where do we or how do we get 2 reds? It can be red red y, or red y red, or y red red. So since it is with replacement, it doesn't really matter. It's just 3 times, it is 3 over 5 times 3 over 5 times 2 over 5. It's exactly 2 reds. Okay, so those conditions are with replacement case. Alright. And without replacement, I have written 2 examples, like what's the probability of choosing all red, for example. It's 3 over 5, then it will decrease 2 over 4, then it will decrease 1 over 3. See, as the red marbles taken, so there is 1 less red marble out of 1 less number of marbles. So 3 becomes 2, 5 becomes 4. Then the next step, 2 becomes 1, 4 becomes 3. So it will decrease. So choosing all 3 red marbles is 3 over 5 times 2 over 4 times 1 over 3. And choosing all the yellow marbles, I said it is 0, but it's actually the same idea. It is 2 over 5 times 1 over 4 times 0 over 3. So that's 0 straight. Okay, so this was the last slide. I hope those questions help you to understand some tricky parts or basics in probability and counting principles. I wish you good luck. All the best in your exams.